Hello students, I am Amarjeet Singh and I will be taking your subject ME 402N. We will start the syllabus unit wise, coming to unit 1. Introduction. We start with the brief history of automobiles. This is the year. And these are the events, important events which took place during the development of the automobile. It was in the year 1769 that Captain Nicholas Cugnot of France built the first road vehicle propelled by its own power. The speed at that time was 2.5 miles per hour in 15 minutes. Thereafter, after about 32 years, in 1801, the first steam carriage was operated in England. In 1832, the first 3-speed transmission in England. In 1880, the Germans and French built first IC engine. In 1895, the first motor car race took place. In 1897, the first motor car arrived in India, by ship, of course. In 1908, the first T model car of Ford produced 20,000 units. In 1943, the first automobile was produced in India at Hindustan Motors Limited, Calcutta, and Premier Automobiles Limited at Bombay. Germany is the birthplace of automobiles. Coming to the definition, the automobile is a self-propelled wheeled vehicle. The important point in this, it has to be self-propelled. Now, tractor-trailer, a tractor pulling a trailer, 4-wheel trailer. The tractor is a vehicle, but the trailer does not run on its own power. It is not an automobile. Similarly, in a train, the engine is an automobile, but the bogies behind it, because they can be separated, is not an automobile because it does not move on its own self-propelled power. Now let's come to the components of an automobile. This is the first lecture and I will only be introducing the components. Each of these components will be studied in detail as we progress during the course of instruction of this subject. The various components are the basic structure, transmission system, the controls, power plant, auxiliaries, and the superstructure. Serial 1 to 5 constitute the automobile chassis. Coming to the basic structure, there are two types. The conventional pressed steel frame, which we see on the roads, even for cars and heavier commercial vehicles. You could say more than 90% of the vehicles have the conventional pressed steel frame, over which the mechanical components are attached, and on top of that the superstructure is fitted. In frameless construction, there is no frame it's like a enclosed body, and in this, since there's no frame, all the forces which come on a vehicle will be on this construction. That means even the pillars, the windscreen, the side doors and the other parts, they will all be load bearing. Fine. Let's come to the suspension system. Now, what are the objects of the suspension system? The first is to prevent road shocks to the vehicle components as well as the passengers which may be in the vehicle. Secondly, to maintain vehicle stability in pitch and roll while the vehicle is in motion. What is pitching and rolling? Pitching is, if this is the front of the vehicle, this is the rear, this is pitching. Rolling, like a boat on the sea, it rolls left to right. This is rolling. So, stability has to be maintained in both these forces. Now, what are the types of suspension system? Basically, whenever we talk, we will be talking about the basic automobile, the car, and other vehicles, commercial vehicles, light commercial vehicles and others. First is the conventional system, where the road springs, you must have all seen on the side, road springs are attached to the rigid beam axles. They are attached by the means of two U-bolts and tightened from below with a nut. So, the road springs are integral with the beam axles. This needs to be noted. The second type of suspension is the independent suspension. In this, there is no rigid axle beam, and each wheel, that is, if there are four wheels, each wheel moves independent of the other. Let's say there's a stone comes, that particular wheel will rise up, and after crossing the obstacle, a stone or a, let's say, speed breaker, it will rise up, the remaining three won't. And after crossing the obstacle, it will move down. So, this means that each wheel moves freely, vertically and independently. Let's come down to the axles. Generally, there are two axles, front and rear. What are the objects? First, we must consider the axles as beams supported at two ends. The springs are attached to it at the spring center, which is subject to loads. The axles are subject to loads. What are those loads? There are four types of loads. First, the vertical load at spring center, which is nothing but the weight of the vehicle and its occupants. The second load, forward and backward at wheel centers due to driving or braking efforts. As you know, if you're traveling in a vehicle, when it brakes, the occupants tend to move forward. It means these forces are subjecting to the vehicle too. Similarly, when you accelerate, if you've noticed, when the vehicle accelerates, you are thrown back in the seat. Similarly, the same forces are on the axles. Third force is the torque reaction due to drive or brakes. We will be studying this in detail, but briefly to mention, torque reaction is nothing but, consider that, let's say to understand it, consider that the propeller shaft is rotating, giving drive to the wheels. If the propeller shaft is rotating and you somehow theoretically manage to prevent the wheels from rolling, what will happen? There is a bevel pinion and crown wheel, the differential, that will try to move over it and try to lift up the vehicle as a torque. That force will come on the front end of the, this is the springs, the front end. Similarly, when it breaks, the force will act on this and try to distort this spring like this. If the spring is like this, it'll act here and this will be clear when we come to the subject of axles. It will become crystal clear what exactly this torque reaction is. The fourth load coming on the axles is the side thrust of the tire due to centrifugal force on turn. You know, when a turn takes place, the centrifugal force will act on the wheels, center of the wheels, and that is a force also to be reckoned when the vehicle is turned. Now talking about axles, let us see the three types of live rear axles. I am only mentioning them because we will be studying each one in detail as we come to that particular subject in the units ahead. Fully floating type. The second type of live rear axle is 3/4 floating, and the third type is the semi-floating type. This is just an introduction. We will study in detail. Wheels. Now, sufficient to mention in the introduction that wire spoke wheels are used on sports cars due to lightweight and ability to be changed quickly. The light alloy wheels which we see today on the roads is used in luxury or big sports cars, and they are called Formula wheels. Coming to the power plant, the power plant is nothing but the engine, internal combustion engine, maybe a 2-stroke, a 4-stroke, and there are various other types of IC engines and other engines which we will be studying in detail subsequently. Now we come to the transmission system. Let us first have a look at this diagram of the transmission system. This is the front of the vehicle, the front axle, front wheels, rear axle. Engine, this is the engine. Engine is flywheel connected to the propeller shaft, and through the clutch the drive goes to the transmission, or what we other popularly known as the gearbox. The output shaft of the gearbox is connected to propeller shaft through two universal joints. Universal joints function is to, if the drive is at an angle, as you know, this is higher, engine is higher than the rear axle, so it generally goes down. So to maintain the slope of the propeller shaft, the universal joints corrects the angle to the desired angle at which it must rotate. From there, it goes into the differential. In the differential, there is first the final drive. This is that which I was mentioning earlier. This is the round wheel and a bevel pinion, and the final drive is a system of gears, beveled gears, from which there are two half shafts. These are two half shafts which are connected to the wheels. This is the general basic layout of the complete transmission system of an automobile. All these components constitute the transmission system. So what is the function of all this transmission system? The first is to connect the engine to the wheels when the driver desires. Self-explanatory. Secondly, to connect the engine to the driving wheels without shock. That means there should not be a shock, means through the clutch. Gradually we release the clutch and gradually the connection is made. Third, vary leverage between engine and the wheels. Leverage is required because the engine speed is very high, thousands of RPM, and by the time it reaches the road wheels, we want a lower revolution. This is affected at three places. First is in the gearbox. You have gears 1, 2, 3, 4, 5 even. The second is the final drive, and the third reduction takes place in the differential. The final drive reduces the drive from a range of 4:1 for cars, and it is about the reduction in heavier vehicles, trucks and bigger vehicles, is around 10:1. This is the amount of reduction. The reduction also increases the tractive effort. As we know, a heavily loaded truck, fully loaded, will require a lot of tractive effort to move the wheels initially. So this is helping towards that objective. The next is reduce the engine speed in a fixed ratio. This is done by the gearbox. When we study the gearbox, we will see the various ratios. There will naturally be 4 ratios. If there are 4 gears, there will be 4 ratios. And each ratio of each gear is fixed. Next is to turn the drive through right angle. The drive is coming from the engine, propeller shaft, and it has to be turned through right angles, so that the half shafts give the load to each rear wheel. The sixth point, the function is to make provision for flexing of road springs, causing a relative movement between engine and wheels. If you have seen a tractor pulling a trailer and the trailer does not have any road springs, it makes quite a racket on the road. Thump, thump, thump. It just jumps up and down, because there are no road springs. If there were no road springs in a car, you can well imagine if someone is traveling, he will be tossed around, the head hitting the ceiling repeatedly. So, this is the meaning of this. So, you have to make provision for flexing of road springs. Road springs are meant to be flexed to cause a relative movement between the engines and the wheel. Auxiliaries. Auxiliaries. The supply system, electrical supply system, battery and generator. Starter. In a starter, the motor initially will require around 150 to 500 amperes. And the circuitry is such: primary coil, secondary coil, and a Bendix drive which finally connects the pinion of the flywheel, which causes the engine to rotate. The ignition system, there are three types of ignition systems currently. One is from the battery, magneto, and electronic. In magneto, it's nothing but a small generator with primary and secondary windings, and there is a iron magnetic rotor, which gets the drive from the engine, rotates and produces current, which is through the windings is fed to various parts of the engine. Electronic, a timer is used instead of the conventional contact breaker point, CB point. And this system is called ECU, the electronic control unit. The timer sends this, let's say, to a spark ignition engine at interval as per the design. Ancillary devices. These includes radio, lights, air conditioning, wiper motor, various, all those are called the auxiliary devices. The controls. The controls are the steering system and the braking. These two aspects control the movement of the vehicle, which is in the hands of and in the feet of the driver. In the steering system, what is important is we will be studying the steering system. This is, in fact, this whole lecture is just an introduction. Each of these components, as I said earlier, will be studied in detail. I am just introducing various terms and what are the various parts. The important thing to note here is the wheel alignment. We all know we go and align our four-wheelers periodically, time to time, 8,000 to 10,000 kilometers. What is wheel alignment? Nothing but positioning of the wheels, correct position of the wheels, correct angle of the wheels to achieve the following. Firstly, to achieve directional stability during straight ahead position. Vehicle is moving straight, it should continue to move straight in a straight manner. We'll come to that. Cycle you have all driven when you were children. Sometimes while driving the cycle we leave the handle and the cycle continues to move in the forward direction without turning left or right on its own. That's called stability, directional stability. How it's achieved, we will study when we reach this topic. Secondly, there should be a perfect rolling condition on steering. There should be no wobble of the wheels. On the road you must have seen number of cars where they have not got it done. Alignment, the wheel wobbles. The rolling of the wheels should be perfect rolling condition. There should be no sway here and there and no shocks here and there. And the thirdly, it is after you complete the turn, the wheels, the recovery should take place and the wheels should come back to the forward driving position, straight ahead position without much effort by the driver. The brakes, the second type of controls is the brakes. The requirements of braking are Firstly, the brake should be strong enough to stop the vehicle in minimum distance, keeping in mind the safety of the vehicle. Minimum distance. Secondly, the brakes should have good anti-fade properties, that is, the lining material should be such that the effectiveness should not decrease on prolonged application. But this is research, a lot of research has been carried out on the material of brake lining. We will cover that subsequently. This is not achievable, but if it can give an increased life, it is desirable. After some time, generally 20,000 to 40,000, 30 to 40,000 in a car, the brake linings need to be changed depending upon the driving habits of the driver. If he brakes too often, the brake linings will get worn out quicker. Briefly, let's look at what is brake efficiency. Ideally, we would like, when we press the brake, the vehicle should come to standstill in zero distance. This is not possible, but then let us see. What is the definition of brake efficiency? When the coefficient of friction is unity, the total retarding force at the wheels is equal to vehicle weight. Need to understand this. That is, the vehicle will experience a deceleration equal to acceleration due to gravity. This is a little technical, probably not able to understand, but when we come to the brakes, I will explain it to you in greater detail. You just need to know that 100% brake efficiency is never possible, it is not achievable, because the momentum of the vehicle, you know what is momentum, mv squared, that cannot be made to come to a halt all of a sudden. The types of brakes, just briefly, just to mention, as I said, we will cover later. Types of brakes may be mechanical, there may be hydraulic, there may be servo brakes, there may be air brakes, and the latest is the electronic wedge brakes. This is all for this lecture. Next lecture, we'll progress as per whatever the topic mentioned in Unit 1. Thank you.